Okay, I think we can start, right? So first of all, we're recording. We will be sharing recording. We will be sharing slides towards the end of the session, like one slide before the thank you slide. There's going to be a huge QR code which you can use to download everything you're going to see today, and we'll update it within a few days with the recording of this webinar. So, feel free to take screenshots, but everything will be published online. Within the next 55 minutes, you'll get the QR code that leads you to basically GitHub repo with everything you're going to see today. Okay. My name is Anton. I'm a principal solutions architect at AWS handling serverless technologies. Today, I got Joe with me, who's my peer on the cloud ops side of the house, and Rob, who's I guess our peer in CrowdStrike, right? Amazing security company that probably everyone is aware of. Okay. And we wanted to talk today about how would you build event-driven multi-account activity monitoring solutions in the cloud. So this is going to be a technical session. We'll start with the use case, and then we'll gradually go deeper and deeper into technology. What are the different options of building this solution? You'll see some examples, right? You'll hear from Rob how these technologies are actually implemented at a huge scale at CrowdStrike, right? So we wanted to share this with you because the technology, right, and this whole industry of cloud security is continuously evolving, right? So, you got new channels and products in cloud security all the time. Be you a cloud security vendor, or maybe you're part of security team in a large enterprise or AppSec, right? There are always something new going on in the cloud security domain, right? But it's not just about channels and products. It's also about threats, right? If you're familiar with the notion of CVE, right? New CVEs are discovered pretty much almost daily, right? So you always have some new threat vectors that you as a security person, as a security company, need to protect against, right? Growing customer expectation. That's also very important. Once again, whether you are a vendor, an official vendor, or a security team, your customers, your consumers, they have expectations, right? So when new threat is discovered, they want to make sure you know how to address that, right? And something that is very relevant in cloud security industry is, in many cases, what's considered innovation yesterday is kind of becoming a commodity today. A stark example of that is probably multi-factor and second factor authentication. 10 years ago, that was a pinnacle of technology, right? 5 years ago, same. Today, it's kind of commodity. Everyone has it, right? Because it became a standard in security. So, since there is evolution, it only comes with challenges, right? Now, the challenges can fall into different buckets, right? So, for example, I wanted to start with non-functional requirements. We'll obviously get to functional stuff as well, right? But there are important non-functional requirements. So, rarely you will get the luxury of starting from scratch, right? Not having any technical depth or existing infrastructure to maintain, right? So when you're building your products and evolving new capabilities, you would usually have some legacy stuff that was created 2 years ago, 5 years ago, etc. You have to continue maintaining that, right? And this can also kind of roll up to high operational costs, meaning, in order to innovate, you need to address that problem, right? Because innovation also costs money. There are functional commodities, right? Things that are kind of expected from you just by the virtue of you being a cloud security expert or vendor or team, right? You're expected to be real time. No one cares about whether you discovered a vulnerability or threat if your insights come 3 days later, right? You're expected to detect that in real time or close to real time, right? So hours is a lot. Minutes, okay, debatable. Seconds, amazing, right? And as you grow, right, and the volume of your tenants grow, you need to process massive volumes of cloud activities and cloud data, right? And today, this is kind of commodity, right? This is expected from you, right? It's not something, a bonus feature. Another aspect is customers trust and privacy assurance. So, as a cloud security team or vendor, you would usually reach into accounts of your tenants to get that activity or to do some security scanning, and this can be considered invasive, right? So you want to do it in a way that your tenants will, not worry about, hey, am I letting that vendor, do too much in my account? What about trust, right? Another factor is also cost sharing. Okay, because if you're doing something in the account of your tenant, there might be a cost to it, right? So if you're running some agents, for example, there is a cost to running those agents. So cost sharing is in place as well. And obviously, features, 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 right? You're rapidly adding product capabilities in a highly competitive market, right? The use cases can range. We scoped session today to threat detection and activity monitoring. So the common use cases are keep track of continuously changing cloud assets inventory, right? If you're part of enterprise, you know that enterprises usually have hundreds, if not thousands, AWS accounts. And, as a security team or vendor, you have to continuously monitor what's going on with the inventory of resources within these accounts. Identify assets that are out of compliance with your guardrails or regulatory frameworks, right? So whenever something becomes out of compliance, you want to know about it immediately because maybe it's going, to affect your next PCI or SOC 2 review. Track and audit user and operator account activity, right? To detect suspicious behavior in real time. When suddenly someone is deleting like 50 keys from TMS from a country they've never been before, I would consider that a suspicious activity, right? And you want to know about it like within seconds, not next day, seconds. The last one, monitor assets for security vulnerabilities. For example, things like storing secrets in clear text or using some, vulnerable dependencies, etc. So there are quite a lot of use cases. And the thing is, you have to modernize your stack continuously, right? So I really like this quote from Michael Werlo. He's a research VP at Gartner. Technology and service providers that fail to adapt to the pace of cloud shift face increasing risks of becoming obsolete or, at best being relegated to low growth markets. I think you all know what we're talking about here, right? You need to reinvent yourself continuously. You need to evolve. The way we like to talk about this modernization process here at AWS is, commonly we're presenting this modernization cycle, right? And one good thing about this cycle is you don't have to start in the top left, right? Reduce operating expense. You can actually start in any one of those items, right? So, just for the sake of the discussion, let me start with the second top left, right? Focus on business value. I think it's kind of self-explanatory. You as a team that delivers security capabilities or as a cloud security vendor, you want to make sure that your focus is on delivering value. No one cares what kind of technology you're using under the hood. You can use the latest and greatest version of some framework, but if that's not helping you to deliver business value, that's a big problem. So if you do focus on business value, it will lead to innovative capabilities, right? And that will obviously lead to happier customers, which will lead to improved customer retention, right? When your customers are staying with you, right, you can actually start exploring advanced business opportunities with these customers. And you can tell them, you know what, now I'm providing even more capabilities that you might be interested in. And those customers trust you, right? So they have a higher propensity to adopt that. When your company grows, obviously you're going to get higher employee engagement, right? That's not just external, that's also internal. Employees of your companies, they love when you're working on cool, new, innovative stuff, right? So employee engagement grows as well. And you want to turn that into a repeatable process. Obviously, you want to continue the cycle for as long as you go, right? So, the way I like to kind of put it, this modernization cycle, it's an opportunity to demonstrate industry-leading product capabilities and customer experience, as well as reduce expenses through the use of evolving technologies like GenAI, serverless, event-driven architectures, etc., etc., etc. But the big question is, okay, how you actually do it, right? It all sounds great, right? And looks great on this slide. but how do you actually do it? How do you build something and evolve it into something that will be innovative, something that will help us to address the use cases that we are discussing today? And the way I like to present it is we'll actually build something together, right? We're gonna call it Acme Shield. It's a fictitious real-time threat detection cybersecurity company. Okay, Rob, it might be a little bit competing with CrowdStrike, right? So we want to show how might such a company, a fictitious company, think about building security product that handles following use cases, right? That's exactly the use cases we've described before. Cloud resources inventory and change tracking, compliance and governance policies violation detection, operator and user activity analysis, threat and suspicious activity detection, basically stuff that you expect from a cloud company. Now, if we look at the topology of such a solution, right, on a very, very high level, this looks something like this. Okay, that might look something like this, right? So there are multiple, we call them tenant accounts, right? Accounts where activity happens. And there is also that Acme Shield vendor account, right? This is essentially where activity data is being sent from the tenant accounts, right? State of the resources, what happened to those resources. And this is where Acme Shield will process that data, right? And detect vulnerabilities, provide insights, and so on and so on. So to make this, a little bit more structured, I like to split it to three different parts, right? There is a collection segment, right? This is where activity data and state needs to be collected, right? There's a transport stage where that data needs to be transported from hundreds, thousands, sometimes tens of thousands of tenants account, depending on your scale. It needs to be transported for processing in a centralized location, right? And it actually needs to be processed, right? And we'll cover additional steps a little bit later. So the focus of today is going to be on collect and transport, right? I would imagine if you're a cloud security vendor, you have your kind of secret sauce of how you actually process the data. That's your intellectual IP. If you're a cloud security team, you probably have some tools that you use to process the data. So the focus of today is going to be how the data is collected and how do you efficiently transport it from thousands of accounts across account boundary into that cloud security vendor space. So let's start with collecting data, right? And here, Joe, do you want to take this part?
Sure. Yeah, let's do that. Sorry, 1 second.
Yeah, we can hear you.
Yeah, okay, great. I'm here. So collecting data. How are we going to do that? And let's go ahead and just go to the next slide and we'll jump in. All right, so the data starts within the tenant accounts, like depending on what services you're using. We have over 250 plus services here. So a lot of your clients that are collecting the data, the security teams that are collecting the data, they're running from various services. Can you go ahead and click on the next slide? And you take the resource state of the actions that have happened, and you're going to pull from your vendor account, the Acme Shield account, to the tenant account to kind of see what has changed, right? Point in time from when you do that polling. Go ahead, next slide. This has very distinct advantages. It's real time, right? So when you choose to poll, that's when you're going to get the state across those various services, right? You're going to get that specific resource state, and it's good for a first time inventory building. But as you grow, and like Anton talked about, hundreds, thousands, tens of thousands of accounts and many, many services running within there, it starts to exponentially grow the amount of data that you have and the amount of API calls that you need to make as you're polling. So some of the considerations is you have to maintain that polling infrastructure. As you grow and scale, it becomes more and more massive and much more complicated to maintain. There's lots of redundancy of getting the same state for services that haven't changed, right? You're collecting everything from all of those services. That consumes your API quota. So like, as you can imagine, you jump, as you're growing, if you have hundreds of accounts, maybe, it could be millions of requests. It could be hundreds of thousands of requests. As you move into the thousands, tens of thousands of counts, it becomes hundreds of millions or potentially, even more than that as you're polling these services for your tenants account, right? And you don't really have a way to handle the incremental changes. So you'd have to look at a state before your previous polling period and compare that to the new polling period that you just took and find the differences. Next slide, please. All right, so what is an event? Let's talk about that, right? It's just a signal something's changed on a system. Something has happened. So what does that look like? Next slide, please. So an event is typically a JSON object, right? We mentioned it's something that has changed. Let's kind of take a brief look at the event here, right? In the detail type section that we've highlighted in the box, we can see an object's created from the source that's S3. So an S3 object has been created. Down in the detail block, we can see that it was the object that was created was in bucket, my awesome bucket, and the specific object was my awesome object, right? So we can see that at the time that's listed in the event, in this specific account, in this region, that an object was created in S3 for this specific object from this source IP address down at the bottom and via a put object request. Right? These are things that happened in the past. You can't change what's happened in the past. It's something that has occurred, right? From these events, the top half of it above detail is where the metadata is, the thing like ID, the detail type, source, account, time, region, etc. Within the detail section contains the specific things that have changed. What has changed on that system as a part of an event, right? And from there, in EventBridge, all of our services at AWS, not all of them, most near all of our services, 250 plus services, emit events to EventBridge, right? So you're able to see what type of activity is occurring on your accounts and your services or your customers' accounts and services via EventBridge through these events. Next slide, please. All right, so kind of back to collecting the data in an event-driven fashion, right? So your tenants emit that data via the services. Just by default, AWS is getting to have those services send to Amazon CloudTrail. CloudTrail captures different activity that's occurring within your accounts, like everything from like mutating changes or non-mutating, like describe and list, right? Those types of actions. That is listed in an event history within CloudTrail, where you can see what the event is, what the event time is, username, etc. There's a lot of other great data. But one of the things that's really nice is by default, AWS has CloudTrail send those events to EventBridge. And EventBridge lets you take action on the events as they happened. We mentioned polling before, right? So when we were looking at polling, you choose when you're going to have your polling timing to where say, hey, I'm going to check, see when things changed across everything. With the events that are emitted to CloudTrail, which are then sent to EventBridge, you're notified when changes have happened. So you don't have to do that comparison. You just know what has changed and when it changed. Next slide, please. Oh, so let's kind of start going through the event, right? We start with the event time. We know when this event has occurred. Next one. We also now see underneath that the user identity. So who made that change? We can see, someone did it via a role, what that role was, from what account it's in. And then next slide. And then one of the other things that I want to talk about here that's kind of really important with the details from the CloudTrail events, right? We have source IP, so we can know where it's specifically coming from. And something that's actually really important for kind of understanding what's taking the action is the user agent feature. So the user agent is a particular principle that interacts with an AWS API. So for example, if I'm clicking around the console, I'm using Firefox, you'll see that the action was taken from Mozilla, right? If you were doing something programmatically with AWS CLI, you'd see AWS CLI, or if you were doing it with like a Python SDK in Boto 3, you'll see it's actually happening in Boto 3, right? Another thing is that user agent field also potentially contains operating system where you could see OS, Mac OS, or Windows or something like that. But why is that important, right? When you can take the event time, you can take that user identity to know like what role, what user's taking action, the source IP address, where it's coming from, and then what's actually making that request. You can start to put that all together to understand what actual real user behavior looks like and potentially what malicious user behavior looks like that doesn't fit the patterns of normal usage for your application services and the workloads that are running in AWS. Next slide, please. Right, so what are some of the advantages about this, right? You get detailed data about those account and activity changes that are built into CloudTrail and the way that the services function today, right? It's integrated with over 250 services. Almost all of our services send events to CloudTrail, which then send them to EventBridge. You don't have to worry about maintaining the infrastructure or the scale of CloudTrail, right? Or EventBridge from that matter. It just works, right? It supports AWS organizations to send all your CloudTrail data as a part of your organization to a single account. And you don't really have to worry about managing the infrastructure. That undifferentiated heavy lifting is just part of the services. The one key consideration here is you still need to find a way to transport the events from tenant to vendor accounts. That's what Anton was talking about, like the shared cost model, that part of it, and how customers are going to send that to you. There's always a cost involved with all of that as well. So let's go ahead and move to the next slide.
Thanks, Joe. Thanks.
Yeah, you're welcome.
Yeah, so now that we've kind of identified that the easiest way to collect that activity data is through using CloudTrail, right? The next question is, okay, so I got the data automatically fed into CloudTrail, but how do I actually transport that data across accounts, right? How do I actually put an arrow between tenant account with CloudTrail and Acme Shield, whatever the ingestion mechanism is going to be? Now, there are several options. What I call a traditional approach, and traditional, again, without any negative connotation, right? It's just something very well established, right? Is to use the native capability of CloudTrail to export data to an S3 bucket, right? So this is something that CloudTrail can do automatically. It's a built-in functionality. And when a new object with activity data is created in the bucket, you can send, again, not you, right? S3 can send a notification basically saying, hey, a new object was created in this bucket, right? At this point, the Acme Shield control plane will retrieve that new object, right? And unzip it, parse it, and start processing data. Okay. Now, there are, as usual, advantages and considerations to this approach, right? The advantages are it's extremely simple. It's probably as simple as it gets. There is no complexity there whatsoever, right? And it's been used for years. This approach works for years, right? For many security companies and security teams, right? Another advantage, it's also pretty cheap for tenants, right? S3, if you're storing data in S3 and that's not exactly data you need frequent access to, right? It's relatively cheap for tenants, right? So they're just paying the cost of storing those objects in S3, and there is no additional costs of sending activity events from AWS services into CloudTrail, unless we're talking about data events, right? Control plane events, not charged for. Okay. However, there are considerations. It's kind of all or nothing, right? There is no filtering or conditional routing, right? Everything goes into CloudTrail, right? So the objects that are you getting from S3, they will contain everything, right? So it's up to you on the Acme Shield side to actually understand what you do need, what you do not need, right? It's not real time. Events can be delayed for minutes, right? So it takes time for CloudTrail to accumulate those events, and it does not store them in S3 immediately. It can take several minutes, right? So it's not real time, which means usually you're going to get higher mean time to detect. It does require vendors or security teams to continuously maintain infrastructure for downloading and unpacking potentially millions of those S3 objects, right? So you still need to download that object, unpack it, which is a compute intensive operation, right? And only then you can process. Once again, contributes to higher mean time to detect. And another important factor, it requires inbound IAM permissions, right? So in order to get that object, Acme Shield must reach out into tenant account, right? So inbound IAM permissions. Yes, you can scope those permissions to bare minimum to a very specific bucket in a tenant's account, right? But still, it's inbound IAM. It can open a can of worms when you're discussing, what exactly you're going to be doing in that account. So what's the alternative, right? What are other ways of actually transporting events across accounts? And Joe kind of alluded to one of them, right? So like we said, CloudTrail automatically delivers events to EventBridge. And as long as those are control plane events within the same tenant account, this is also free. There is no additional charge for EventBridge ingesting events from any AWS service, control plane events, management events from any AWS service within the same account. It's free. And moreover, you don't really need to do anything for this to happen. It just enabled out of the box, right? You just need to set, to configure whether you want to do something with those events. But those events are sent out of the box, right? Now, let's talk a little bit about what EventBridge does, right? And how does it help in this scenario? Now you can see here that I only have a single arrow going from tenant account into Acme Shield, and that says push events. So EventBridge changes the model a little bit, right? So instead of using the polling model, it will actually proactively push events into whatever destination you define. So let's take a look a little bit of what EventBridge look like internally, okay? So it's a fully managed serverless AWS service, right? We call it Event Router, serverless event router. And the idea of Event Bridge, it can ingest events from hundreds of sources. You can define rules of how those events should be routed, right? Some of them might be filtered out, others enriched, right? And eventually, Event Bridge pushes those events to over 100 of different targets, AWS services, HTTP endpoints, partner integrations, etc. So it's a serverless event router capable of processing huge volumes of events. Okay. Now, using EventBridge got its advantages and considerations. So from the advantages perspective, it's simple, it's serverless, it just works, right? Like I mentioned, events flow to EventBridge from services through CloudTrail. It all happens automatically. You don't need to enable it, right? And there is no additional cost for it. Again, emphasizing as long as those are not data plane events, right? Management control plane events, there is no additional cost to it within the same tenant account. It just works. It saves you from a lot of redundant polling using API calls, right? So now Event Bridge will automatically push changes to Acme Shield, right? You don't have to poll for state updates every few minutes, every few hours, right? But essentially, the volume of polling through API calls is reduced significantly, right? If not to zero. It's real time. Events are pushed to vendors, choose Acme Shield as they occur, right? So you will get that event commonly in a low single digit number of seconds. Okay, so it is quite real time, right? Something is happening in the tenant account. Few seconds later, you have a notification about that in the Acme Shield account. It's actually pretty powerful. It does provide you flexible filtering and routing rules. You're going to see it in the following slides, right? So you can, configure logic in EventBridge, basically saying, hey, I only care about these specific events. I don't care about different types of events, and I should be delivering them to different targets, right? So very flexible with filtering and routing. And it does require you to have outbound IAM permissions only, right? It's a push model. Acme Shield doesn't need to reach out into tenant account. It's tenant account pushing stuff out to Acme Shield, right? So it's a push model, outbound IAM permissions only. There are also considerations, right? Event Bridge comes with variable cost, right? So Event Bridge charges you based on the number of events, right? So the baseline cost is, again, it's a little bit more complex than that, but the baseline is around $1 per million events, right? So if your tenant is sending 5 million events a month, right, the cost can be $5, right? So the cost depends on the number of events being transported, right? And another consideration is EventBridge. If you're using EventBridge, it will also consume your tenant's EventBridge quotas, and we'll talk about quotas, in 2 slides, right? But this is you as a Acme Shield. You're using a service in tenant's account, So it consumes the quotas that EventBridge provides. Also something to keep in mind. Now, when you're deciding how exactly you're going to transport those events across accounts, EventBridge gives you two general options, right? You can either transport those events from EventBridge bus to EventBridge bus, or it's not just the target can it doesn't have to be EventBridge bus. We support multiple cross-account targets like SQS queues, Kinesis streams, Lambda functions. For simplicity, I'm gonna call this bus to bus, but essentially it's bus, EventBridge bus to another AWS service, right? The idea here is AWS, we manage the operations and scalability and reliability of everything on both ends, right? So you're sending data from one resource owned by AWS to another resource, operated by AWS to another resource operated by AWS, right? You don't need to be concerned with operations of those resources on both sides. That's the top option. The bottom option is you can also use your existing HTTP ingestion endpoints, right? So if you're saying that, you know what, I'm going to build my own HTTP ingestion endpoint, or maybe you already have it, right? Not everyone starts from zero. Maybe you already have existing endpoint that you can use for data ingestion. EventBridge can also send events to that API endpoint as well. We call it API destinations. Essentially, an HTTP endpoint that you operate, right? So again, in the top scenario, we operate the target, right? We manage the operations and reliability. In the bottom scenario, you operate it, right? You can still build it using Lambda, for example, and we're going to operate it, right? Or Fargate, and we're going to operate it. But this is an endpoint that you've created and you manage. Now, let's talk a little bit about differences in these two approaches, right? Because I think it's important to understand when you should use each, right? So bus to bus is by far, or bus to service is by far the simplest to implement, right? It's literally just a configuration. You don't need to maintain any infrastructure whatsoever. It's very simple to implement. Most of the configuration would be IAM permissions and routing rules, right? It does not require any additional endpoints to be implemented on the vendor side, right? We basically push data directly to another EventBridge bus, right? It provides very high transactions per second by default. It would depend on the region, but in the largest regions, it's up to almost 19,000 transactions per second by default. That's the default quota, right? And if you need it, we can talk about raising it, right? But that's a huge number. And it comes with native IAM support, right? So you don't need to worry about securing this segment. It's already secured by default using AWS IAM. You need to configure access policies to make this work, right? The cost for this option is $1 per million events, right? And this cost actually falls on the tenant, right? Not on the vendor, on the tenant, on the source, okay? Bus to API, the second option, it's a little bit different because now you own the ingestion endpoint, right? Not we, you own it. It's your own ingestion endpoint. It's very simple for tenants. There are no changes for tenants from the configuration perspective, right? It's still pretty simple for tenants, right? But it does require additional effort for vendors, for the Acme Shield, right? Because now you need to maintain that infrastructure, that application. You need to build it according to your requirements. The default TPS is 300, right? But we can bump it up to 3,000 if you need to, right? And since this is your endpoint, you're responsible for implementing things like authentication and authorization, and it can be either basic, OAuth2, API keys, etc. Since in this scenario, you're the one who's implementing the ingestion endpoint, the cost is cheaper, right? The cost here is only 20 cents per million of events that are sent across accounts, right? So if you want us to manage the both sides, right, the producing side and also the ingestion side, you can use bus to bus or bus to service scenario. If you're saying, nope, I'm going to manage the ingestion, I might have already an endpoint for that, you can use bus to API scenarios, okay? So let's talk a little bit about best practices that we can apply here for these scenarios. So it's important to buffer your events, buffer the activity before processing, right? If you're ingesting events from thousands of tenant accounts, this can be quite unpredictable, right? Maybe in one of their accounts the team decided to run a hackathon, and as part of that hackathon they've decided to create 500,000 objects in S3. So there's going to be a major spike of activities, right? So you do not want to overload your processing component, right? So we highly recommend that after the ingestion endpoint, right, and here I'm using event bridge as ingestion as well, you implement some sort of component that does queuing or buffering. This can be SQS queue, right? This can be Kafka, managed Kafka or self-managed. This can be Kinesis, right? Essentially a component that is capable of ingesting huge volumes of very spiky data. And then your processing, which again can be Lambda, EKS, ECS, doesn't really matter, Spark cluster, your processing doesn't need to scale as fast, right? And it can just process data from that buffer at its own pace, right? So essentially, you're not overloading your processors because scaling processors would usually be much harder than scaling something like Amazon SQS or Kinesis, which will scale automatically for you. Okay. Another important consideration is, not all events are equal, right? You can differentiate between different events types, right? So, for example, there are control plane events and data plane events. Control plane events can be mutating or non-mutating. So, for example, events like resource created, updated, deleted, that sounds very important from threat detection perspective, right? Resource listed, retrieved, or described, also important, but probably a little bit less critical than resource deleted, right? So you might treat different event types differently. Data plane events, which usually come at a much higher volume, right? You can also identify them and treat them differently. So for example, here, right, you can see that in my tenant account, I have a rule that defines high priority events. I have a rule that defines lower priority events. And anything that doesn't fall under those two definitions, I can actually drop it, right? Which means I'm significantly reducing the cost of my event transport here, right? Because there is no cost for ingesting that event in tenant account. The cost is for transporting across accounts. So if I drop irrelevant events, I'm saving here, right? And to give you a more specific example, for example, here you can see a definition, and this is a screenshot from how you configure event bridge rules, right? If those events are coming from IAM or KMS, which are kind of like security services by definition, right? I might want to send them to some high priority pipeline, right? Something that will get higher priority. But if they're coming from EC2 and EKS, which are compute services, I'm not saying they're not important, right? They're also important. But events coming from IAM and KMS, I might want to treat them with higher priority, right? So Event Bridge allows you to do that easily. Important thing to configure, to consider, sometimes polling is actually still okay, right? And I call this intelligent polling, right? Event Bridge, right? This event-driven threat detection will tell you when a change has occurred, right? And based on that information, you can actually, in your processing, you can make a balanced decision, an intelligent decision, whether you need to poll for additional information. So polling might still give you something, some additional context that is not available in that JSON payload of the event, right? It might happen. Maybe you're getting an event about state change in EC2 instance, but you want to collect a bigger picture before you make a decision whether it's a threat or not, right? But you're not just blindly polling every 5 minutes or every 10 minutes, like, are we there yet? Are we there yet? Are we there yet? No, you're waiting for notification. Okay, something changed. And now you can add intelligent polling for when a resource state have actually changed, and you can do additional investigation. Okay. So to bring everything together, right? You can use CloudTrail to collect the data, right? Those events are automatically funneled to CloudTrail, right? Then, in order to transport those events, you have an option of doing that with, basically just dropping events from CloudTrail to S3 and then, retrieving those S3 objects. It works. It's very simple. It's not real time. It might have some latency, right? If you want something super real time, you can use EventBridge to transfer those events across account in real time, right? And you can obviously combine these options. You can send some events, critical events, as real-time events through EventBridge, and stuff that is less critical, you can use S3 for it because it's okay to have like a 5 to 10 minute delay when you're processing those events. The last thing I wanted to talk about is how do you complete the cycle with our SaaS partner integrations, right? So we talked about a scenario where tenants are sending their activity events into vendor, but it can be other way around. Vendors can also send activity events back to tenants, and we have several dozen partner integrations. You can see some of the logos here, right? These companies, they also send events to EventBridge. So for example, let's take Auth0 as an example, right? When something happens, users are trying to authenticate, authentication failure, they can actually deliver those events to EventBridge. So you, as a customer of Auth0, you can implement automations based on that, notifications or maybe some changes in your applications, etc. Right? So the default scenario that we've discussed is tenant sending events to Acme Shield, but the other way around is also possible, right? So SaaS partners can publish events to a designated partner event bus. In your account, you would know that that event is coming from a partner like Acme Shield, like CrowdStrike, like Auth0, etc. Right? And tenants can subscribe to those events and trigger event-based automations, right? So, for example, when Acme Shield starts by collecting data, right, processes the data to provide insights, it can actually send back an actionable event, right? And in the tenant account, you can have a custom remediation action, right, to actually address that actionable event. This is on a high level what it's going to look like internally. So on the Acme Shield side, there is ingestion, then processing. That processing produces insights or findings, and from that point on, Acme Shield can send an event, actionable event, back to the tenant. In tenant's account, you might have, for example, a Lambda function that implements remediation for this problem, right? And that function will, let's say, update the service that needs to be updated, right? For example, security group with, super wide permissions, right? Well, let's address that. That will once again generate event in CloudTrail that you can, through EventBridge, transport to Acme Shield. And now you have a closed cycle here, right? So Acme Shield detected security vulnerability. It reported that vulnerability back to tenant. Tenant had automation that addressed that vulnerability. And once the vulnerability was addressed, tenant reported the new state to the Acme Shield. So now Acme Shield actually knows that the vulnerability was indeed addressed, right? So now it's actually a closed cycle. This is what it can look like end to end, right? Collect, transport, process, and notify, right? Make sure it's not just one-way street, right? You can also have it as a complete cycle for the best experience of your tenants. Okay. And with that, I do want to pass it to Rob, so he can actually present a CrowdStrike story.
Thanks, Anton. And thanks, Joe. Um, Definitely a very exciting presentation so far, and so many things that you've mentioned really ring true for our story as well. Next slide. So for folks who are not familiar with CrowdStrike, just a few words about who we are to kind of set the stage for how EventBridge helps CrowdStrike help customers stop breaches. Um, so CrowdStrike, if you do know CrowdStrike, something that is not necessarily well known is that we started as a services company providing primarily incident response and investigations for customers who experience breaches. We developed our Falcon sensor as a response to help us more rapidly gather telemetry to help us accelerate our incident response. And that sensor has become a cornerstone of our security platform. Our single agent architecture is super easy to deploy on multiple operating systems with no reboot. Collects all of the system activity that happens on an operating system, and with onboard AI sensors, able to figure out if what system behavior it's seeing is indicative of an actual attack in progress, and then is able to take automated action to stop that attack. The sensor can't always understand every attack that's happening, and we have threat hunters in the background, investigators, continuously 24/7 looking at over 1 trillion events per day from millions of endpoints, crunching that data, really looking for a needle in a haystack to see what is the next zero-day attack. And when we see that attack, we can detect it from the data that our agent is sending up to the cloud, where all of this trillions of events are being processed at scale in near real time to find out what's happening and stop the attack, even if the sensor itself couldn't do it on the first pass. So our agent is only part of our data story. We're also pulling in data from third-party sources. One of our biggest sources is AWS CloudTrail. CloudTrail has been kind of a cornerstone of this conversation because CloudTrail is the AWS service that is able to provide a feed of all of the changes that are happening primarily at the control plane layer. And what we're able to do with that is see if any activity that's happening on the control plane, again, is an indicator of attack for something that might be happening in near real time inside of AWS. For example, a common example we talk about is when attackers break into someone's environment, they're very particular about covering their tracks. So if a customer has logging, let's say S3 bucket logging, and S3 is a target of the attack for data exfiltration, one of the first things that a threat actor will do is disable that bucket logging. That bucket logging disabled event is captured in CloudTrail and delivered in near real time through EventBridge. So that kind of sets the stage. Now, I mentioned before, we have threat hunters, we have investigators, and we release reports every year about trends that we're seeing in the adversarial environment to help customers prepare for for what's coming down the pike. We all hear on a daily basis about generative AI, agentic AI. Generative AI is really helping security teams accelerate. It's also helping cyber adversaries accelerate. So where there were only maybe a handful of cyber adversaries, threat actors that were able to take advantage of very sophisticated sequences of attacks, now with generative AI, adversaries have been given like a real boost in being able to deliver very sophisticated attacks very quickly. In fact, one of the measures that we track is something called breakout time, and that's the time it takes for that initial access that a threat actor, that an attacker will get a foothold in a single system, an environment, that initial access. From the time of that initial access to being able to move laterally inside of the environment, we call that breakout time. The fastest breakout time that we've observed is 51 seconds. I'm just going to let that sink in for a second. Okay. Many security teams, I'd argue most security teams, are not staffed to manually respond to attacks that move that quickly. So it's essential not just to get that data to be able to detect the attack in near real time, but to be able to respond. And I mentioned before that our agent is able to, when it understands all by itself that there's an attack in progress, it's able to just take action. Like customers able to set prevention policies, to tune those policies, but it's that agent, that Falcon sensor that's taking action. So similarly, for these other attacks, it's really essential that we're getting all of the events from CloudTrail that we use in our platform to detect that there's an attack in progress. We have to get it quickly in order to prevent or slow down or actually stop that lateral movement. We've been talking about our use of EventBridge and CloudTrail to deliver near real-time automated response, detection and response. We've been talking about this for years, and we built our platform on AWS, and we've been working very closely with AWS for a long time. And this slide refers to a blog that we put out a few years back to describe how we use CloudTrail. So when Anton shares the slide deck, you have some links here, and you can see how we've done it in our production environment. Next, please. So what I'd like to show you in the next slide, thank you, is kind of a high-level architecture for how we do this. And I'm going to talk through this diagram, but it really is almost exactly what Anton and Joe just described to us. So we're looking at a component of our Falcon Cloud Security, as I mentioned before. Our Cloud Security has our sensor component that we deploy on EC2 instances in container clusters, delivers sensor-based telemetry. But there's also the agentless component where we have to pull in through EventBridge those events in near real time from CloudTrail. So that component is cloud security posture management. And how do we do it? So the first thing that happens is we have a mechanism for registering each AWS account and region, and we can act on a customer's entire organization, which is really preferable, that customers are using multi-account organizations to to create sort of separate the blast radius and provide function-specific, accounts for non-prod and prod and functional units and things like that. It really helps customers sort of, provide more control in their security infrastructure. So we operate on that level, and we're able to register all of a customer's accounts in CSPM. So how do we do it? It's really simple and really lightweight. We exchange IAM cross-account roles, and we create event bus rules on the customer side that they're able to filter through that CloudTrail stream. We pull out the events that are relevant to our processing or event processing and detection, and we send those events from the customer's bus to our event bus in our application, also running in AWS. So there is a transfer of those events at scale going across the account boundary, but often in the same region. So it all happens very, very quickly. And then once it comes into our side, we're immediately processing that data at scale, adding it to our graph databases for rapid processing and response actions. So again, very, very simple on that side. Now, how we handle all of that volume of data for CSPM is really just part of the event-driven story. It's also essential that we're also making it really easy for customers to stay protected. When customers use AWS, they got to move quickly, right? They've got to deliver more quickly, and they've got to innovate quickly. So there's no time for security teams to assess each individual new instance. So we have event-driven deployment mechanisms that for each new AWS account, for each you can click through this, for each new EC2 instance, for each new EKS cluster, for each new ECR repository, we're automatically detecting that new resource, in many ways through, in most cases through EventBridge. In some cases, like SSM, the EC2 instance comes online, the SSM agent reaches out to us. But these are all events that we're able to capture and initiate the deployment of CrowdStrike protection as soon as that happens. And that's the event-driven story. Thank you very much.
Thanks a lot, Rob.
Thanks, Rob.
All right, we got what, about 2 minutes left, right? So I think it's time to come to a conclusion and share the resources like I promised with you. All right. So uh, let's start with one. Event-driven activity monitoring scales efficiently across large AWS blueprints, right? By shifting from traditional polling or expanding traditional polling to leveraging CloudTrail and EventBridge, you can monitor hundreds or thousands, tens of thousands of AWS accounts in near real time with significantly reduced overhead. Utilize CloudTrail to capture API activity, and EventBridge to route events, right? Implement comprehensive security and operational insights using real-time alerts, right? This will, enable great rapid threat detection, compliance enforcement, automated response workflows, etc. Make informed choices and balance trade-offs when architecting your solutions. You've probably noticed that we had at least 5 or 6 slides talking about advantages and considerations, right? Architecting cloud solutions are frequently about balancing, right, and considerations and trade-offs, right? So make balanced decisions. We want to make sure you're well informed about all the options you have, in your inventory, right? As promised, a giant QR code that contains links to essentially everything you've seen today. If you give me a quick second, I will also paste that link in the chat window, right? Okay. Yep. Where's the chat window? Here it is. So this is exactly the same link. This is where QR code leads you. This is the GitHub page with all the information. Okay. I hope you enjoyed the session. I saw several questions in the chat. We'll see if we can answer them. We're right at time, but I think we can stay for a few more minutes. The last thing I am going to ask you is if you can please help us to improve our content further, right? This is a quick survey QR code. So we would greatly appreciate if you can provide feedback about this session. Okay, and with that, thank you very much.
Thanks all.